So, okay, this is first slide. All right, so this is the second slide. So for me, my name is Lin Shen. I think I know many of us from CEE375. So I'm an associate professor at Civil Engineering Department at UH Manoa. So my office is 344 Holmes Hall. Okay, my phone number is here, my email address. Okay, so if you have any questions, you can email me or call me. As we know, all our lectures and also labs will be online for this semester. And here is the online Zoom meeting links. Okay. So I also put this information in the syllabus. Okay. We also have a teaching assistant. I think we are close to decide who will be the teaching assistant. So I will let you know. We will know his name. Okay. All right. So for these classes, because it is construction materials, the topics covered will be in concrete and other construction materials, including wood, steel, and aluminum. But the majority of the content will be on concrete, so including cement and concrete materials. Okay. So these courses will have both lecture and labs. If we have 3 lab sessions, I think Monday 2:30 to 4:20, and Wednesday 2:30 to 4:20, and also Wednesday 4:30 to 6:20. Okay. Because the special situation for this semester, again, everything will be moved to online. Okay. For the lab sessions, we will have lab demonstration. So instead of we doing the actual work in the labs, okay. But still, we need to write a lab report. We have around 5-6 lab report. Some of them are individual lab report. Some of them are group lab report, which means you will read the report as group of around 5 to 6 students. We also have not many several homeworks, and also a research paper, which is also a group effort at the end of this semester. You will choose certain topics on cement and concrete materials and write a research paper together. Also, at the end of the semester, you will present your research paper as a group presentation. Okay. We have a couple of quizzes, several homeworks, lab reports, research paper, the paper presentation. For the exams, we have 1 midterm and 1 final exams. Okay. Okay, so let's look at the syllabus for more details. Let me share the syllabus with you. All right, so this is the syllabus. Okay, again, showing the information of my email, the Zoom link, lab sessions. Again, for lectures, we only have Mondays and Wednesdays. Okay, I think on a schedule, we have Monday, Wednesday, and Fridays, but because we have several lab sessions, for these courses, we only have Monday and Wednesdays. So no Friday lectures. Again, no Friday lectures. Okay, for the office hour, I plan to keep it after the lectures from 9:30 to 11:30 online. If you want to see me at other time, you can let me know. I think I'm pretty flexible. All right. Okay, again, these courses will cover mostly cement and concrete. We talk about what is cement, cement chemistry, how to make concrete, fresh property, hardened property of concrete, mechanical property of concrete, such as the strength and also elastic modulars. Okay. How to design a concrete. Okay. And also some other materials such as steel, wood, and asphalt, as well as steel, aluminum. Okay. For the textbook is called Materials for Civil and Construction Engineers. Okay. Either fourth or third edition will be okay. Several students email me about the textbook, but I will say the textbook is desirable, but it's not mandatory. Okay. To prepare for your midterm and final exam, you should focus on the lecture notes, which I will upload to Laulima before every classes. So focus on my lecture notes to prepare for the exams. The textbook is not mandatory. Okay, so I will say maybe several of you can share one textbook, which will be enough. The major purpose for the textbook is for the lab sessions. Okay, but because everything will be online, also including the lab, so I think several of you share one textbook should be more than enough. Okay. I will give several handouts for you to prepare for the exams, and here are other books about concrete materials for your reference. Okay. Right. Okay. Okay, we will have some in-class quizzes and also homework. Okay. All right. For the lab and report, because everything will be moved online, this is the first time for me, and I will figure out how we can write the lab report together. Probably I will give you some of the raw data, so for you to analyze and write your report. Okay, so let's figure out together as things move on. The first lab session will start around, let's see the schedule, maybe the 4th or 5th week. Okay, so no need to worry about the lab for now. Okay. All right, for a research paper, again, this is group effort. You will read research paper together on the topics you're chosen, and also a short presentation at the end of the semester, which will be counted around 5% of your total grade. Okay, so research paper and paper presentation, 5%. For the final exam, 35%. Midterm, 25%. The lab report is 15%. Okay, but because this course is very intensive class, so lab report is very important. So as you can see from notes here, students who do not complete all writing assignment will get a D- or F, and will not get the W focus credit for this course. All right, and this is the schedule for this course. Okay. Any questions? Okay, so you said you have quick questions for lab session number 2. Lab session number 2 should be Wednesday. Yeah, should be Wednesday, 2:30 to 4:20. Okay, sorry. So to other book reference, is it just to our ledger, or we need to rent it at some time? You do not need rent or purchase the other reference. Okay, So even for the textbook, as I said, it's not necessary for you to purchase. Okay, so no. Okay, so the labs will be conducted online. Yes, 100%. So all the lectures and also all the labs will be conducted online for fall 2020. Okay. Yeah, so OnStar said it will be in Homes Hall 101, but we'll change that. So I already asked the chair to change that. So again, everything will be online. Okay. All right. So this is a syllabus. Let's go back to the. Hold on. Okay, sorry for that. I finally get back to my lecture notes.
CEE.
All right. Any other questions? Okay. So why we should study concrete? The reason is simple. Concrete is the most widely used construction materials. Okay. Actually, concrete is most used man-made materials. It is backbone in our modern day life. Okay. So in the US, every year, each person will use around 2 tons of concrete. Okay. And the value of concrete structure is very good. Okay? The concrete has a very long service life. A well-designed concrete can last for many decades or even hundreds of years. Okay? And concrete is safe generally to fire and some impact. Okay? And the maintenance cost of concrete material is very low compared to other construction materials such as steel, aluminum, and asphalt. Okay? And here in our state of Hawaii, we do not produce steel, so concrete will dominate our state as the construction materials. Okay, almost all kind of infrastructure such as buildings, bridges are made of reinforced concrete. Okay. So here is a video showing us what is concrete.
Concrete is a mixture of Portland cement, water, and aggregates such as rock and sand. The aggregates serve as the filler material in concrete, while the Portland cement and water form a paste, which serves as the glue that holds the aggregates together. Through the chemical reaction called hydration, this paste hardens and binds the aggregates into a strong, durable mass we call concrete.
Mm-hmm.
Okay, I guess everybody has seen concrete being poured before. Okay, so what is concrete? The words concrete coming from Latin words concretus, which means to hold together or formable rock. Okay, in modern concrete, we need material called cement to hold everything together. So inside concrete, we have we call Portland cement, which is a fine powder, we can buy from Home Depot in bags. Okay. So when we mix Portland cement, the powder with water, we have so-called cement paste. Okay? So cement paste is a mixture of Portland cement powder plus water. Okay? And the ratio between the mass of water and the mass of cement is called water to cement ratio. Water to cement ratio is a very important factors, the parameters determine the strength and other property of concrete. Okay. Mortar, probably many of you have heard that before, is cement paste plus sand. Okay, or we call them fine aggregate. When you mix cement paste with sand, we have mortar. So mortar is the materials which we use to glue bricks together. Okay. And the concrete is mortar plus coarse aggregate, which is larger stone in a size about quarter-inch, half-inch to about 1 to 2 inch. Okay. All right. So here is a picture showing us typical concrete, the aggregate, the coarse aggregate. Cement paste plus water. Okay, this is cement powder. Take about 7 to 15%. So water around 16 to 20%. And also a lot of aggregate, including the sand, we call it coarse fine aggregate, and also the large stone, we call that coarse aggregate. Also in concrete, we have very small percentage of air. Okay. So that are the major component in concrete. Right. So why we should put sand and coarse aggregate in concrete? The reason is, first of all, we need to reduce price of concrete. Cement, which is fine powder, is the most expensive materials in concrete. On the other hand, the sand and the coarse aggregate is only cost about 10% of the cost of cement. So the more aggregate we put in the concrete, the lower the cost of concrete. Another reason we put aggregate in concrete is to reduce the shrinkage cracking. Okay. As we will discuss later, concrete is very easy to crack because concrete is very brittle. If concrete shrink for some reason, it will crack. So when we put sand and coarse aggregate in concrete, we can reduce this shrinkage cracking, okay, and make the concrete stronger and less brittle. Okay. The reason we put water in concrete is water will have chemical reaction with cement powder to generate strong materials. We call that CSH. Okay. We'll discuss the chemical reaction of cement powder with water in future lectures. Water can also control the cost of concrete, control the strength as well as durability of concrete, and also control the so-called workability of concrete. Okay. Yeah, can you see the next slides? Looks like I have problems choosing to the next slides. Sorry about the problems. Let me do.
To the same slide.
Yeah, I see that. Sorry. Let me do the. Let me open the lecture notes here on my computer. Sorry about that. Okay. All right. So can you see the buildings? All right.
Yeah.
Okay, great. So here shows some of the famous concrete structures in the world. Okay. So the picture on the upper left is the Baha'i Temple in Illinois, which is close to Northwestern University. Okay. The picture on the right is Baha'i Temple in India. Okay. So that concrete is made by so-called white cement. As you can see, the color is white instead of gray, which is typical color for modern concrete. Okay. Okay. And the picture on the left is one of the tallest bridge in the world, which is the Millau Bridge in France. Okay. The height of the pier is more than 800 feet. Okay. And the picture on the right is one of the tallest building in the world. It is Petronas Twin Tower. Okay, it used to be the highest building in the world, but right now it is belong to the Khalifa Tower, which is in Dubai. So the total height of this building is more than 2,700 feet. Okay. The building has 165 floors. Okay. And the cost of the building is 1.5 billion US dollar. Okay. So I believe currently this is the tallest building in the world. So where concrete is used, concrete actually is used everywhere, as we mentioned earlier. We can use concrete to make Portland cement concrete pavement, reinforced concrete bridges, reinforced concrete buildings, waste treatment facilities, dams. Most of the dams are made by concrete, nuclear reactors, subway tunnels, okay, and you name it. So almost every kind of infrastructure can be made by reinforced concrete, which is the concrete material together with steel reinforcement. Okay. So one word, people like to describe the modern city is, concrete jungle, and you can see the impact of concrete in modern people's life. This table compare the basic property of concrete, which is on the bottom, with other type of construction materials such as aluminum, steel, glass, and wood. Okay. As we can see, the density of concrete is around 23 or 2,400 kilogram per cubic meter, okay, which is similar to rocks. For steel, it's much heavier, 7,800 kilogram per cubic meter. Aluminum, the density is similar to concrete, just a little bit heavier than concrete. Okay. Strength-wise, the compressive strength of concrete for normal concrete at least is only around 30 to 40 megapascal. Okay, or around 5 KSI. Okay, for every 1 KSI is equal to 7 megapascal. Okay, which is much lower compared to steel. Okay, as we can see from here, the tensile strength of concrete is even lower. Okay, only around 10% of the compressed stress of concrete, so around 3 to 4 megapascal. Okay, so that's the reason we want to put steel reinforcement inside the concrete to make reinforced concrete, because concrete is very weak under tension. Okay, we put the rebar in the area of concrete where the concrete will experience a lot of tension or shear, so to make the structure stronger. The elastic modulus of concrete is around 25 to really apply.
Yeah.
Okay.
I was trying to put my laptop on, but then I forgot the
I'm sorry,
Wi-Fi.
Brian? You have a question?
No, no question.
Okay, all right, okay. Yeah, so if you have questions, yeah, you can just send me a message or you can just ask directly. Okay. So the G value, E value of concrete is around 25 to 35 gigapascal. Okay. Still, again, much higher than that. The next is thermal expansion coefficient. Around 10 for concrete. For steel is around 11. This is very important for reinforced concrete because concrete and steel has pretty similar coefficient of thermal expansion. As we can see, 10 versus 11. This make reinforced concrete possible because otherwise, when temperature change, steel and concrete will expand or shrink differently. So that may cause the bonding between the interface between the steel and concrete. And because these two values are very similar to concrete and steel, when temperature change, the reinforced concrete will not crack due to temperature change. Okay. For thermal conductivity, concrete is very low, which is a good thing because concrete is good thermal insulator. Okay. The fabrication energy for concrete is also very low, only around 1% of that of steel. Okay. So that makes the cost of concrete much lower compared to steel. Okay. The pros and cons of concrete. Concrete, as we mentioned before, is very durable materials. A well-designed concrete can last hundreds of years. Some of them can last thousands of years, as we will see in a moment. Many of the historical concrete can last several thousand years. Concrete is also a low-cost materials. And concrete can be formed on site. Before you pour the concrete, we need to set up a formwork, and then we can pour fresh concrete into the formwork and after a couple of days, concrete will harden and achieve the strength. Okay. Concrete is also a very energy efficient materials. It has very low fabrication energy. Okay. The cost of concrete is also low, and the concrete is also inflammable. Okay. It is very resistant to fire. Concrete also have very good thermal resistance. Okay. This also means we can save energy by using concrete. Okay. Concrete is also pretty water resistance. It is immune to corrosion, compared to steel. Okay. The disadvantage of concrete, it is very brittle. Okay. The tensile strength of concrete is much lower compared to compressive stress. Okay. That's the reason we put the reinforcement, steel reinforcement in concrete. Concrete also have a slow material development. Okay. We need several days of curing. Curing is process we put water in concrete to let the concrete achieve its design strength. Okay. So concrete needs several days to achieve its design strength. Another disadvantage of concrete is the strength to weight ratio is also low compared to steel and other construction materials. Okay. And because concrete need to be formed on site, we need labor to set up a formwork and need to wait several days for the concrete to achieve its strength. Okay. It takes labor and time for the concrete to form on site. And one last thing is the volume instability. Concrete is prone to shrinkage problem. Okay, and because concrete is also very brittle, sometimes concrete will crack due to different type of shrinkage. Okay, in the future lectures, we'll discuss shrinkage and creep of concrete. Okay. All right, and here shows some of the historical concrete materials. Okay. Sorry. All right, so one of the earliest concrete is made by ancient Egyptians. The pyramid, which was built more than 5,000 years ago, is made by ancient concrete. We call that gypsum mortars. Okay, we'll talk about the chemical reaction involved with this type of concrete next lecture. Okay, the concrete is reinforced with straw. Okay, which is very interesting because for modern concrete, reinforcement is steel. Around 2,000 years ago, ancient Roman engineer used their concrete to design the famous Colosseum and the Pantheon. Okay, and this type of concrete is made by volcanic ash. Okay, again, we'll talk about these two types of ancient concrete in much more details next time. All right. And here shows idea why we need to put the reinforcement, the steel rebar in the concrete. Okay. The picture on the left showing us a concrete beam with no rebar, no steel reinforcement. Okay. When concrete has a load in the middle, the concrete need to resist the moment. And from early class, CEE375, we know how to calculate the moment the concrete beam will experience. Okay, so the top section of the concrete beam will experience compression, as we can see from the green arrow, and the bottom section, the concrete will experience tension. And because concrete is very weak under tension, so the bottom section will crack early. Okay, so that means that concrete beam without reinforcement cannot resist much moment. Okay, so when we put the steel reinforcement, let's see the bottom picture. On the bottom of steel reinforced beam, which is the green line here, steel is very strong under tension. So the moment the steel reinforced concrete beam can resist will be much higher compared to plain concrete beam. Okay. Another thing is for steel to work efficiently, the concrete must crack first, but very minor crack on the bottom of the beam. Okay. And the steel is placed in the tension zones. So where concrete will experience tension and shear, okay, such as the bottom of this reinforced beam. Okay. And the majority of the steel is enclosed except for the area of the cracks. Okay. Concrete has very high alkali environment, as we will discuss in future lectures. And this high alkali environment will protect the steel from corrosion. Okay. All right, and this slide is showing us the idea of pre-stressed concrete. Okay. The picture on the top showing us the beam, concrete beam in the typical bending. And we know how to draw the moment diagram. Okay. So the middle part of the span, the moment will be the highest. Okay. At the two ends, we have zero moment. The rebar is put in the bottom of the steel beam, as you can see in the middle pictures. Okay. So for pre-stressed reinforced beam, we apply some tension on the steel reinforcement. So that steel reinforcement will apply a compression in the bottom part of the beam. Okay. So before the reinforced beam experience any kind of loading, we have a moment on the beam already. So when we apply the load, as we can see in the bottom pictures, apply the load on pre-stressed concrete, that pre-stressed moment will offset some of the moment. As a result, the highest moment will be lower compared to reinforced beam without pre-stress. Okay, so we reduce the highest moment in the pre-stress beam. Okay, so that's the simple idea of why we need to put pre-stress in reinforced concrete. All right, so in this class, we will talk about all kinds of innovation in concrete. We will talk about different type of fabrication methods, such as precast concrete, okay, shotcrete, or pumpable concrete. What is extrusion or very high flowable concrete, such as self-consolidating concrete. For normal concrete, we need consolidation for the concrete to fill every corner of the formwork. But some of the concrete, such as self-consolidating concrete, does not need any type of consolidation. Okay. We'll talk about different type of curing techniques, such as steam curing or curing use microwave. We'll talk about admixtures, including silica film, flash, and slag. So these materials are industry byproduct of waste materials which we put into the concrete to modify the performance of concrete, okay, and also reduce the cost of the concrete. Okay. We'll talk about different type of aggregate, such as lightweight aggregate or recycled aggregate, okay, to make the concrete a sustainable approach. We'll talk about chemical admixtures, such as superplasticizer, which can make the concrete very flowable. Okay. We'll talk about air entraining agent, which will make the concrete durable to resist a certain type of chemical attacks, such as alkali-acidic reaction. Okay. We'll talk about SRA, which is called shrinkage, reducing admixtures, which make the concrete less crack. Okay. We can also put latex or polymer in concrete to enhance the performance of concrete. We can also put reinforcement, not only steel reinforcement, but also fibers. We call that fiber reinforced concrete. Okay. All right. So again, in future lectures, we'll discuss different type of innovations in much more details. All right. So here, talk about question of scale. When we look at a concrete with naked eye, we see a concrete is very homogeneous materials. Okay. But when we look at a concrete in a meso scale, which in a scale of centimeter or millimeter, okay, around level of inch, we see concrete has cement paste and also has sand as well as the coarse aggregate. Okay. But if we put the concrete in micro scale level, look at the concrete in nanometer level or micrometer level, concrete will become a totally different materials. Okay. So again, we will talk about this in much more details in the future lectures. Topics covered in this class, we will talk about different components. What is cement? What type of cement we can use for concrete? So there's 5 different types of cement depending on applications. We will talk about sand and coarse aggregate. We also talk about different type of chemical and mineral admixtures, to modify the performance of concrete. Okay. We'll discuss chemical reactions involved with concrete, as well as what are the product. We call that hydration product. The chemical reaction between cement and concrete, we call hydration. Okay, so cement will react with water. We have different type of so-called hydration product. We also learn how to design normal and high-strength concrete based on what material we have and what are the requirements for the concrete. Okay. We will study early age property of concrete, how to measure the slump of the concrete. Okay. I believe many of us has heard about slump test. Okay. And also the setting time of concrete. The setting time basically is how fast the concrete can achieve its design strength. Okay. We talk about mechanical properties such as strength, different failure mode, fracture mechanics of concrete, and also long-term definition such as shrinkage and creep. Okay. For shrinkage, we have about 5 or 6 type of different shrinkages depending on the reason for shrinkage. And also creep. Creep is similar phenomenon in concrete as shrinkage. Again, we'll talk about that in later lectures. Durability issues, we'll talk about physical and also chemical attacks potentially for concrete materials and how we can design and maintain a concrete to resist different type of physical and chemical attacks. Okay. We also talk about testing method, both destructive testing method and the non-destructive testing method for concrete. Okay. We'll talk about special concrete such as fiber reinforced concrete, self-consolidating concrete, gel polymer concrete, and so on. Okay. And at the end of this lecture, this class, we'll talk about steel reinforcement, wood as a structure, and also asphalt as the construction materials. Okay. All right. So requirement for this class, we will learn different terminologies. Okay, we will remember a lot of new words such as hydration, what is CSH, and so on. Properties, we need to understand what are the important properties for concrete and other type of materials. Methodology, we will understand how to control the property of concrete. We will learn how to design concrete for different type of applications. And field applications, we need to apply the knowledge we learn from the lab, okay, which is virtual for this semester, and also from the lecture for your future job site. Okay, and also we will learn how to study concrete and other type of materials in more scientific ways. Okay. All right. So the key idea for the first lecture of this class, you should think, how does concrete compare to other building materials such as steel and wood? Okay, so concrete is strong under compression, but weaker under tension. So concrete is a very economical materials, and the concrete has some major components such as cement, water, sand, and coarse aggregate. Okay, so what are the strengths and the weakness of concrete compared to steel? Okay, and the concrete must be understood at what scale so we can design and use these type of materials more efficiently. Okay, so these are some of the questions for you to think after this class. All right. Okay, so I think that's the end of this first lecture. Any questions? If you have questions, you can just send me a chat message, or you can just speak right now. Okay. So I will upload lecture notes to Laulima before the class, and I will record lecture after this and try to upload to YouTube as I did for CE305. So if no other questions, I will see you on Wednesday, 8:30. Okay. Thank you
Thank
very
you.
much. Thank you.
Thank you.
Thank you. See you.